This is set number 4. We start off question number 1. It says a proton collides with a stationary alpha particle. You know what a proton is? Okay, a proton is one of those particles that's in the nucleus of an atom. If you've taken chemistry, you'll for sure know what a proton is, right? Everybody's done it in Science 9, Science 10, but we might forget. In the end, it doesn't really matter for our purposes today what a proton is, any more than it matters what an alpha particle is. Most of you probably have no idea what an alpha particle is. It doesn't matter. The context of a question doesn't matter. It's the meat of a question that matters. As long as you know the mass of a proton and the mass of an alpha particle, and those are on our data sheet. Check your data sheet. It tells you that the mass of a proton is 1.67 times 10 to the minus 27 kilograms. And it tells us that the mass of an alpha particle is 6.65 times 10 to the minus 27 kilograms. As long as you know their mass, you don't need to know what they are. We will learn a lot more about protons and alpha particles as the year goes on, especially in our last unit. But right now, it doesn't matter. Okay, they're particles that collide with each other. The proton collides with a stationary alpha particle. So we're going to say M2 is the mass of the alpha particle, but we're going to say V2I is 0 meters per second because that alpha particle isn't moving initially. Now, after the collision, it says the proton moves at this speed opposite to its original direction. If I'm going to say its original direction is positive. Okay? If its original direction is positive, then I'm going to say V1F, the proton after, is moving at negative 3.35 times 10 to the 6 meters per second. Does that make sense? I made it negative because I want my original direction to be positive. You could have very well made your original direction negative and your final direction positive. That would have been okay. This is just the way that I chose to do it. The alpha particle moves after the collision in the same direction as the proton was initially moving. So I'm going to say the alpha particle's final velocity, V2F, is 2.25 times 10 to the 6 meters per second. I'm going to make it positive because it's moving in the original direction of the proton. Make sense? In the end, V1F, V2F, one of them's got to be positive, one of them's got to be negative. It doesn't really matter which one is which. This is the way that I chose to do it, okay? And I'm going to be consistent with this through the whole problem. I want to find the initial speed of the proton, so I want to find V1I. And I'll tell you, I think almost the biggest issue with these conservation of momentum problems that we have is the givens. We got so many subscripts, right? M1, M2, V1I, V2I, V1F, V2F. Like there's all kinds of subscripts here, and it just gets confusing after a while. Keep those straight, and you should be good. Okay, we're going to say PI is equal to PF. We're going to say M1 V1I plus 0, because the alpha particle's at rest, equals, they do not stick together, so we're going to say M1 V1F plus M2 V2F. Good. Let's sub in some numbers here now. M1, kind of running out of space here, but let's say M1 is the proton 1.67 times 10 to the minus 27. This is what we're solving for, V1I, plus 0, because the alpha particle is at rest before the collision takes place, equals M1, 1.67 times 10 to the minus 27, times V1F is negative 3.35. If you could read that. Negative 3.35 times 10 to the 6 plus M2, which is the mass of the alpha particle, 6.65 times 10 to the minus 27, times V2F, which is positive 2.25 times 10 to the 6 meters per second. So here's what you should do. Get this number. It'll be negative. Get this number. It'll be positive. Combine them. Add the two together. And that's going to give you a number on the right-hand side. Then take this number over by dividing. So combine the right side, get everything there, take that number over by dividing. And when we do that, we should get a V1I value of 5.61 times 10 to the 6 meters per second. 5.61 times 10 to the 6 meters per second. I have a note here, actually, that the answer key that I had online was wrong. I think I said 5656 or something like that. Or did I change that? Change it? Okay. Okay, go ahead.
The negative in the question is wrong when it says like it should be A point BC times 10 to the negative B.
That's a good question. Maya, you're right about that, actually. This should be A decimal BC times 10 to the positive D, not 10 times 10 to the negative D. When we look at the numbers that we have here, right, all the speeds are 10 to the positive 6. We wouldn't expect the final speed to be 10 to the minus something, right? So that's just a typo. That won't happen on a test. It won't happen on an exam either. Okay? It just happens in something like this because we don't always catch those things. We don't pay quite as much attention to these things as we do the really important ones. So the answer is 5.61 times 10 to the 6. And we're going to express that as 5616. Now, multiple choice question number 1 is a good one. It says a clerk working at a local food store is asked to retrieve an empty shopping carts left outside by shoppers. Each cart has a mass of 20 kilograms. The clerk places 8 carts, which are locked together. So really we have 160 kilograms here, right? Okay, 160 kilograms. Close to this entrance on a slight incline. There's another 12 carts, okay, that's 240 kilograms, pushes them toward the store entrance. The first 8 carts roll toward the 12 carts with a speed of 2.3 meters per second. So the 8 carts were moving one way, the 12 carts were moving the other way. When they hit each other, they stop. Make sense? You can picture this, right? Bunch of carts going one way, a bunch of carts going the other way, they hit each other and they all stop. We want to know the speed of the 12 carts just before impact. So we're going to say M1 is going to be 160 kilograms. That's the mass of 8 of them, right? We're going to say M2 is going to be 240 kilograms. That's the mass of 12 of them. I'm going to say V1I is 2.3 meters per second. So the 8 carts are moving at 2.3 meters per second initially. I'm looking for V2I. And I'm looking for the speed of the 12 carts before the collision takes place. There is one more thing that I have here, actually, if I read between the lines a little bit. What's that one more given that I have, Sean? You do have the total mass, it's 400 kilograms, although it's not actually going to matter here, but you do have it, you're right. What else is it, Sean? VF. Yes, good. VF is 0. And I'm not going to say V1F or V2F. I mean, V1F is 0, V2F is 0, but since they're coming together, why don't we just call it VF? VF is 0. So I'm going to say now PI is equal to PF. If we have an isolated system, and we do have an isolated system, if there are no external forces acting, which means we're looking at just before and just after the collision. If we have an isolated system, then PI is equal to PF. We have 2 objects before. So we have 2 terms. And then afterwards, we have 1 object. But why don't I just simplify this a little bit? Asher, what's the momentum of all of these carts after they hit each other and come to stop? Yeah, they stopped, right? They all stopped. So why don't I just write in a 0 there, right? I could write in M total times VF, and Sean, you said the total mass is 400 kilograms. I could multiply 400 by 0, and guess what I get? 0, right? Okay, M1 is 160. V1I is 2.3 plus 240 times V2I equals 0. So let's take this over to the other side, solve for it, and then take it over to the other side by subtracting, and then divide it by 240. Then we should get V2I here is equal to 1.53 meters per second. It actually should be negative, actually, shouldn't it? Negative 1.53? But what are they asking me to solve for here? The speed. And the speed of Negative 1.53 is just 1.53. It's the magnitude of the velocity, right? Good. Okay, numeric response number 2. A 2,100 kilogram van collides with a 1,200 kilogram car at rest. They lock together. They move off at a speed of 4.5. What's the initial speed of the van? Let's call this one M1. Let's call this guy M2. What's at rest here? Something is going to be 0 meters per second. Some velocity is 0 meters per second. Is that V1 or is that V2? Sarah, V1 or V2? V1. The 2,100 kilogram van is at rest. The 2,100 kilogram van collides with a 1,200 kilogram car that is at rest. So what is it? V2. Good. It's V2. Is it V2I or is it V2F? V2I or F? Okay? It's I. Good. V2I, 0 meters per second. Good. They lock together and move off at a speed of 4.50 meters per second. What are we going to call this? V what? V1 or V2? Or just V? Just V, because they lock together, right? Is it VI or VF? VF, yeah. Now, what are we looking for? The initial speed of the van. Now we're looking for V1I, right, Sarah? Okay, the initial speed of the van. Okay, isolated system, no external forces. Okay, immediately before, immediately after, we can say PI is equal to PF. Two objects before, M1 V1I plus M2 V2I. What's the final going to look like? We're going to say M1 V1F, M2 V2F, or what are we going to say here? Andrew? Yeah, let's just call it MT, M total times VF. Good. Subbing numbers here. 2,100 times V1I is, that V1I is what we're looking for. 1,200 times V2I, oh, that's 0, right? V2I is 0. I could have just written down M1 V1I plus 0 if I had noticed that, right? Equals the total mass. That's going to be 3,300 times VF 4.5. Would you expect this V1I to be bigger or smaller than 4.5? Bigger or smaller than 4.5? Before we even calculate anything, bigger or smaller? Bigger? Yeah. Look, we have to have the same momentum before and after, right? If we have the same momentum before and after, but the mass goes up, well, then the velocity must go down. If the velocity goes down, then V1I must be bigger. In fact, it is. When we solve for it, it works out to be 7.07 meters per second, which is bigger than 4.50. It is bigger. For those of you who have trouble with that little alligator greater than less thing that you learned in grade 2 or grade 3, 7.07 is bigger than 4.5. Good. And our last one here. We got some bumper cars going on here. It says they operate on electricity. Not that that really matters for this question. We got a collision taking place here, right? Car X and car Y are going to collide head on. X is traveling at a constant velocity of 2.25 to the east. Y is traveling at a constant velocity of 1.30 meters per second to the west. Probably makes sense to draw attention to those east and west, right? So we don't forget a positive and a negative. I'm going to say M1. Are they the same mass? No, they're not. 1.25 times 10 to the 2, or let's say 125. And we're going to say M2 is 161 kilograms. I'm going to say V1I, car X, that's object number 1, is 2.25. Car Y is V2I. V2I is 1.30. Is that right? Is that right, Spencer? 1.30? What's wrong? Yes, correct. It should be a negative 1.30. Good. If after the collision car Y is moving at 0.526 to the east, tell me what that is. Is that V1 or is that V2? V1 or V2? Aaron, V1 or V2? The 0.526. It is V2. You're looking for or you're given the velocity of car Y. So it's V2, and it's going to be V2F, right? And what are we looking for here? We're looking for V1F. But they're all pretty much the same, right? Like, there's slight variations, but the way we tackle them, they're all the same. Context can be completely different, but the problems themselves aren't really. We're going to say M1 V1I plus M2 V2I equals M1 V1F. Same thing we always go through. Masses, nothing cancels here, except units. Is there ever a time when M could cancel and I'm left with just V's, velocities? What? Yes, if they all had the same mass and they don't stick together. Okay, that's what I was kind of hoping for when I saw this question of two bumper cars. Maybe they have the same mass and it saves me some work, but they don't. It's not a big deal. 125 times V1I plus 161 times V2I. Don't forget the negative. Yeah, I mentioned this before in your first written response test, which is quite a while away, quite a ways away. Your first multiple choice test is Thursday after the break, but your first written test is quite a ways away. I've told you this before, I'll tell you again. Your question is going to be, in part, a collision between two objects, between two cars. And one of them is going to be going north and one of them is going to go south, just like we have here, right? East and west. One of them is going to be a positive, one of them is going to be a negative. There's going to be probably a quarter of you that forget to put a negative in there. Okay, we have to remember that something is positive and something is negative when we're opposite directions here. Okay, don't forget that. M1 is 125. V1F is what we're looking for, plus M2, which is 161, times V2F, which is 0.526. All right, so get this number, add them together. Well, it's like subtracting, right? Because the second number is a negative. Get this number, and then take it over to the other side by subtracting. And then divide by 125. And when you do that, you should get lightning fast calculation here, negative 0.102 meters per second, which is 1.02 times 10 to the negative 1 to the west. Is that okay? Make sure, like you watch me do this and you're like, oh yeah, okay, I get that. Yeah. Make sure that you can actually do it. Right? Okay, when I watch Sidney Crosby bat a puck out of the air on his forehand and then bat it out of the air again on his backhand and put it in the net, I look at that and say, okay, I think I can do that. But unless I actually practice it, I can't. I mean, and the odds are pretty good even if I practice it, I won't be able to do that. But my point is that you can watch something all you want and think like, okay, I understand how he did that, but not be able to do it unless you actually practice it, right? So if you got this question, great. Or any of the other questions, great. If you didn't get them, that's fine. They're practice. So what do you do them for? It's practice. But make sure that you can get them. Not just, oh, I understand what the teacher did, but make sure that you can get them yourself now after we've gone over them. Okay?